everyone, we're going to identify and graph the polar equation r equals 2 minus cosine of theta. This is a Limacon. I'm going to show you the form for that in just a moment. Right now, let's test for symmetry because we're going to have to graph this. So the first thing we want to test is this condition 1 and see if our graph is symmetric to the polar axis by replacing theta with negative theta. So basically, if we get the same equivalent equation, it's going to be symmetric. We know that cosine of negative theta, cosine's an even function, so this just turns to positive. So we get r equals 2 minus cosine of theta, which is equivalent to our original equation. So this test passes, and our graph is symmetric with respect to the polar axis or the x-axis. The second condition is symmetry to the y-axis, which is theta equals pi divided by 2. And what we're going to do is replace theta with pi minus theta. So we have r equals 2 minus cosine. Instead of theta, we write pi minus theta. This has the form of our sum and difference formulas has this form here. So let's expand this. We're going to get 2 minus cosine of pi, times cosine of theta plus sine of pi times sine of theta. All right, sine of pi is 0, so that goes away. Cosine of pi is negative 1. So this is going to end up giving you r equals 2 minus a negative cosine of theta, which equals 2 plus cosine of theta. These do not equal because it doesn't equal 2 minus cosine of theta. So a condition 2 fails. It's not symmetric to the line or our y-axis. Let's look and see if it's symmetric to the pole. This is the easiest test. You just substitute in r with negative r. And clearly it does not equal the original equation. The only time this test passes is when you have r is r squared, which is the Limacon here. When we have r squared. We'll get to those, or actually I already have a video on this one. Alright, so basically it's symmetric to our polar axis. This is a Limacon without an inner loop. And that's because, and I know this is hard to see, by the way, these are on my Facebook page if you ever want to save a photo. So my A equals 2, and we're at cosine, so we're this first one. And my B equals 1. This is a 1 here. Since my 2 is greater than my 1, it's a Limacon without an inner loop. It almost looks like the cardioid. I say this is more of an apple shape, and the cardioid looks more like a heart shape. So that's how I see it. It's a little more wider in this area here. So let's go ahead and graph it. Since it's symmetric to the polar axis, we're going to choose the symmetry. We're going to assign values to theta from 0 to pi. So we set up a table and assign values. So let's start with 0 and we're going to pi. 0, pi divided by 6, pi divided by 3, pi divided by 2, 2 pi divided by 3, 5 pi divided by 6, and then pi. And then our equation is 2 minus cosine of theta. So let's substitute in our values, and we're going to get 1. And for pi divided by 6, we're going to have 2 minus square root of 3 divided by 2. That's approximately 1.1. At pi divided by 3, we're going to get 3 halves, which is 1.5. Pi divided by 2, we get 2. This one's going to be 5 halves, which gives me 2.5. And this one's going to be 2 plus square root of 3 divided by 2, which is approximately 2.9. And at pi, we get 3. So let's plot some points. At 0, we're at 1. So here we go. 0 goes to 1. Right here. So we're looking for our angle and then go out. At pi divided by 6, we're at 1.1, so it goes out just a bit. At pi divided by 3, we're at 1 1/2. At pi divided by 2, we're at 2, which is here. And at 2 pi divided by 3, we're at 2.5. I'll put it halfway there. At 5 divided by 6, we're almost close to 3. And at pi, we're at 3. So let's kind of graph this. Goes like this. Now, it's symmetric to this axis here, the polar axis. So we're going to swing this around and graph some more. So I'm checking my denominators here. So this is going to come back in a little bit. This was 1.5. This was at 2. And at 3, we had what? 1.5. Here we go. 1.5 is about there. And then we get really close to 1. So swing that around. And there it is. Almost looks like a circle. Thank you. Have a nice day. Bye-bye.